Hi students, MCQ number 2. A particle executing SHM crosses points A and B with the same velocity. Having taken 3 seconds in passing from A to B, it returns to B after another 3 seconds. Then the time period is to be determined. Now such problems you will have to understand, read many times and try to understand thoroughly. We have studied, in the case of a simple pendulum you take, it is first suspended in the mean position. When it is taken to the extreme position and it is dropped, it moves towards the mean position, then overshoots due to inertia, reaches the extreme position. So what is the velocity of the pendulum bob at the two extreme positions is 0. Is it not? The left extreme and at the right extreme position, the velocity is 0. Similarly, while coming down or while going up, the velocity of the pendulum bob at the corresponding points will be same. Corresponding points. For example, as per this given problem, we can take the midpoint as the mean position. On left side of the mean position O is A, and at the same distance on the right side from the mean position is B. Then only the velocity of the body VA must be equal to the velocity of the body at B, namely VB. That means what? OA is equal to OB, distance. So A and B are corresponding points. That is why the velocity VA is equal to what? The velocity VB. Okay. Now how much time does the body takes to travel from A to B? From A to B, it takes how much? 3 seconds. Okay, they are given. It has taken 3 seconds. Then again after B, in passing from A to B, it has taken 3 seconds. Then it returns to B after another 3 seconds. That is the clue. That is the clue. So beyond B, it is going towards the right extreme position and then returns back to B in 3 seconds. So I have taken that the extreme right position is N. So after reaching B, it travels towards N and returns from N to B. Since it is simple harmonic, the time of ascent must be equal to the time of descent. Therefore, this 3 seconds can be divided as 1.5 second from B to N. And returning from N to B, it takes another 1.5 seconds. Okay. Similarly, on the left extreme position, let us take it as M. So, the point corresponding to M, that is the point corresponding to N on the left side is M. So, the time taken from A to M must also be what? 1.5 second. Then M to A back, it must be what? 1.5 second. So now, what is the time taken for half of the oscillation? Half of the oscillation is from M up to N. So that is 1.5 plus 3 plus 1.5. So if you multiply by 2, you will get the total time period of oscillation. Is it not? So the total time period is given by T is equal to 2 into 1.5 plus 3 plus 1.5. So this is 2 into 3 plus 3. So this is 2 into 6, that is equal to 12 seconds. Okay. So what is the option is C. Therefore, option C is the correct answer. Okay, I hope you must have understood well. Fine.